Welcome back to Quick Math. Today here with Daniel, working on SOHCAHTOA.
SOHCAHTOA is a simple way to use sine, cosine, and tangent to find the missing side or angle of a right triangle. Today we will be focused on finding missing sides. So SOHCAHTOA is an easy acronym. You follow it, this S is sine, and that equals opposite over hypotenuse, same way going down, that the C cosine equals adjacent over hypotenuse, and T tangent equals O opposite over A adjacent. And if you look at an example right here, that shows x degrees is whatever angle it would be, and the opposite is directly across. The hypotenuse would be across from the 90-degree angle, and the adjacent is next to the angle right here. So then we'll start off with one problem. So the first step is identify the opposite, adjacent, and hypotenuse in this problem. So we see the opposite is right here. The adjacent is directly, so the opposite was across from it. The adjacent was right next to the angle, and the hypotenuse was across from the 90 degrees. And so then we use that, and then we determine if it's sine, cosine, or tangent. And if you look at it, sine is the opposite over the hypotenuse. If you look at this, the opposite side is what you're given 4, and then over what you're trying to find, x, the hypotenuse. So this one you would use sine. And then the third step is setting up your ratio. So you set up your ratio by, you're finding the sine of 31. I like to put over 1 equals, and then you find O to H. So what is the opposite over the hypotenuse? The opposite is 4 over x. And then whenever it's in this scenario where sine of 31 is the opposite diagonal from x, so this would simplify it to x equals 4 over sine of 31 because the sine of 31 and x switch places. And then this would equal, although you don't have a calculator, this would equal x equals 7.76. And there's the first problem. On to the second problem. You do the same thing. The first thing is you identify the adjacent, hypotenuse, and opposite. I already have that here, but if you look directly from the angle is the opposite. The hypotenuse is directly across from the 90-degree angle, and the adjacent is right next to the angle. And so then from there, you determine if it's sine, cosine, or tangent. And if you look at it, we're given the adjacent and the hypotenuse. If you look at these, the only one that you're given the adjacent hypotenuse is cosine, so you follow the rule and you do C, cosine, so we identify it's cosine, equals adjacent over hypotenuse. So that's where we go to our ratio. So we get cosine of 42 over 1 equals adjacent over the hypotenuse. The adjacent is 4 over the hypotenuse, which is x. And that would simplify it too. You switch these two, switch them out, then you get x equals 4 over the cosine of 42. And then same thing, that would come out to 5.38. So there's the second problem. On to the third problem. So same steps. First thing you do is you identify the adjacent, opposite, and hypotenuse. You look at this. Opposite from 52 degrees, so this is the opposite. And then right next to it is the adjacent. And then across from the 90-degree angle would be the hypotenuse. So then on to the second step is you determine if it's sine, cosine, or tangent, which if you look at it, the two values are x and 4, the adjacent and opposite. Which ones involve adjacent and opposite? That's tangent. So identify its tangent. And using SOHCAHTOA on TOA, you set up your ratio, t equals O to A. So then the tangent of 52 over 1 equals the opposite over adjacent. So opposite of 52 is x, and the adjacent is 4. So it equals x to 4. And from there, this one you don't switch them because the value besides x is at the bottom. So it's just x, you switch these two. So it's x, or no, you don't switch, but it's x equals 4 tangent of 52. And that will come out to x equals 5.12. And there's the third problem.
But what if in a triangle you're not given a 90-degree triangle? We'll cover that in our next video.